computer. So we're looking at information physics, event time space, which is what I called it a couple of decades ago. It's still relevant. We have time equals Planck's constant over energy, which is the delay of an event exhibited by an event. And then we have x equals ct, which is distance is a delay of a certain time at the speed of light. I don't know if we should have put that as t equals x over c. I don't know. What would be clearer?
Either way, I'm just trying to get in my head what the different, symbols are, because I'm visual. Like, that's what I do. I try and see what it means. I try and visualize what it means.
And I contend
right.
the only two constants in nature are Planck's constant and the speed of light. All else is emergent, and it's the result of
All right.
time.
Well, I got to visualize both of those. I can visualize the speed of light, but Planck's constant, that is just the distance, of kind of the smallest building blocks of the universe.
It's the energy.
No, that's Planck's distance.
Yeah. Okay.
I was thinking of Planck's distance.
Yeah. Planck's constant is in the units of action, and it's the energy of a quantum action of going from one state to an adjacent state. It's the granularity. So what is
a state to an adjacent state?
Well, it can have an energy of 1, or it can be in the lowest orbital, or it can be have an energy of 2, be in the second orbital. The distance between those two
right,
states.
and adjacent.
An adjacent state is really, these are momentum states, and we have to think of them as possible states of the universe. If we make one action, what state can we be in? An adjacent state is one right next to this one, so that with one quantum action, you can get there. Okay. And each quantum action, well, it doesn't necessarily use energy, but the energy difference between momentum states of the next higher momentum, you can actually have a state change to the same energy, because energy is a relative concept. It doesn't have to be a higher energy, but if it changes energy state, the distance between states is one Planck action, one logical action, one action in quantum logic, one matrix transformation in matrix mechanics. So if you have unary quantum mechanics where the only values you have are 1 and I,
psi.
Square root of -1, it's it's just another dimension. Every quantum action is into a new dimension, unless it can line up with existing dimensions logically. Okay, if you have more than 2 variables in the quantum system, it has to be more than 2 dimensions. Each variable is a dimension. And each dimension is orthogonal with every other dimension, unless it can line up. So you covered a lot in the title there, but we can go on. We're trying to talk about the nature
Well,
of
I still want to,
information and the information of nature.
real quick, I want to review it in my mind. I want to see if I can get an intuition as to why. So H is Planck's constant, which is the energy of one action. Is it that it's that energy difference of one action?
It's actually in the units of action. It's not in energy, but it's joule seconds. So the energy. So we can talk about the energy that
Cool.
the Planck. Well, the Planck energy is actually the maximum energy. They don't talk much about the and about the minimum energy of one state change. Carver Mead, a student of Feynman, great teacher, calls it fluxoids. These quantum actions are fluxoids. It's flux. Flux is in action units.
Yeah, it's an energy, not per unit time. It's an energy second.
All right.
I had a question of something you said. I lost it though. All right, so I have to like visualize that. So you have energy second. What's an energy second? It's energy happening for a second. And what would dividing it by an energy look like? I'm not quite sure, but
okay. Well, any
oh, I just got it. I got it.
any two things related by a constant can be considered manifestations of the same thing. So time is the reciprocal of energy.
Whoa.
The frequency.
I have never had somebody put it to me that way, meaning I've never put that 2 and 2 together. Geez, that would have simplified my whole life in the sciences, which I didn't probably get that deeply into because precisely I didn't get simple things like this. Anyways, wow. Okay, yeah. So that's you saw what I was kind of stumbling through. I'm just trying to make sense out of that, and so yeah, you're basically saying time is a manifestation of energy.
Right. The delay manifest, the local time manifest is quantum. It's equal to 1 cycle at the frequency. In other words, it's boom. Energy and delay together. Okay, the inversely related. So,
Well, you said delay, but that's over at this equation. Oh
well,
yeah, because we have
time,
time over here. And that will,
yeah, I'm suggesting that all time is delay. Time is introduced by delay. It's not something that progresses automatically globally. There's no global clock. There's no, time is relative generally.
yeah.
But
Mhm.
so the only time there is the time that's constructed by events, and the events introduce time as Planck's
Oh,
constant
dude.
over energy.
It's Planck's. Holy shit. Okay, I gotta slow down and get Planck's. You said what introduces time? Events. Events introduce time
The only thing
as
happening in the
Planck's
universe is
constant
events.
over energy. Right. That's very Buddhist, I believe.
Yeah, they understood this
Everything's in motion, right?
in the Tao 2,000 years ago. Or more.
Right. Okay, man, there's so much coming together. But the one I exclaimed about, and then I had to move on to what you were saying because it was another thing. But the thing I exclaimed about is that, right or wrong, one of my simple list, we can wipe this away, but right now I just feel like the universe is just a fractal embeddings of toruses the whole way up and the whole way down. And kind of and I watched this other guy that he's like, the Greeks knew this, blah blah blah, and he shows like the energy. He shows magnets and how they do their that shape and back into the middle, and so like I associate the white hole of where the information is coming out as like where sort of the event begins. And so everything you just said, it just clicked, and I was like, oh, okay. An event is where an event creates time. That's what's happening in a torus. It's the white hole end of the torus, like the greater dimension is coming into being at the white hole. It's creating time at the white hole, which you can also call an event, which is what you're saying. So is that bringing a torus into it? Is that just irrelevant and that's not even correct thinking in your world? Or am I relating it to something you know about?
Well, in first approximation, the universe is a hypersphere. Okay, where every point is at the center.
What's a hypersphere?
At a center. It's a four-dimensional sphere. Okay, it's a sphere where every point in the sphere is at a center of a circle. Okay, and also every point is on the surface of the sphere. So if we look at the universe, okay, we can say every point is the center of the universe.
Right.
And as we go out further and further back in time, we get toward the singular point of the apparent Big Bang. So so from the Big Bang perspective, we're on a sphere 13.5 billion years from that point of the Big Bang, so to speak. It's a very fuzzy point, but I'm trying to see if you can get the picture in your mind of us being on the surface of a sphere that expanded from the time of the Big Bang. Let me, I don't know if
Right. And
I have that slide in here probably.
and the
not.
sort of the expansion of the surface of the sphere is our action. It is our motion because it's creating time as it goes along, I guess.
Yeah. You see, we have a picture of that. We don't. Darn it. Let me put a picture in there quick. I don't know where it'll go.
Nice.
But,
So I'm wondering, well, I need to get the sphere, hypersphere a little bit better. I think I can visualize what you're saying, that we've been expanding a sphere since the beginning of the universe, and we're 13 billion, in diameter sphere. I think I get that. And how as the surface progresses, we're creating time. I don't quite get that the surface of the sphere has circles at every point. Or like what do the circles at every point on the sphere mean? But we'll get to that. Oh, and maybe your picture will help. Oh, okay, cool.
Not too big. Oops. I think I screwed it up. Yeah. Okay, so every event created time. And that expanding circle is made by the increasing of time. Okay, and it's,
Can I ask a quick question?
Yeah.
So basically right here, am I like moving along history?
Yes, to some
Okay.
point, at some point in the universe. Now,
Right.
to get back to your question, okay, the toroid is a more accurate representation, but it's impossible to draw. Maybe you can draw it, but the certainly we've had the vision of a toroid. We can see that recurring in space all the time. That the rings of Saturn, whatever, the shape of the galaxy. I mean, there's a suggestion, and that's one of the things, is how does the two-dimensional events create a three-dimensional world? And it's sort of can be thought of as toroid. Obviously, I don't know. So in any case, we have space, which is composed of time delays, events from billions of years ago that are just happening now. And those events are in space now, so to speak. Okay, so all this left-handed quantum logic is in the blue here. It's the space. Okay, but for every left-handed action, there
Real
must
quick,
be
you,
an
you have it labeled as
equal and
red.
red is the
You
right-handed
said
matter.
left-handed.
Oh,
Um,
yeah. There's different views on that. How we describe handedness. That's fine. Yeah, left-handed matter, right-handed space is fine. They consider the photon to be right-handed generally. Thanks for the correction.
so you're still saying that
The blue is
that
space, and that's we're saying space for the purpose of the discussion here. We're saying it's right-handed.
okay, cool.
Because it spins. You hold up your right hand, the direction of spin by your cup fingers shows that the thumb points in the direction of travel of the photon. But in any case, what that means is that each twist in space-time, each quantum creation operation creates an equal and opposite twist in space-time that's two-dimensional. We can think of it as being lateral
Okay,
and
say it one more time.
transverse. Each quantum action, or each difference created, the only way matter or energy is created out of nothing is by creating equal and opposite potentials that add up to zero. So you haven't
Yeah,
you haven't unbalanced things. You have equal and opposite.
right.
And I'm suggesting that and there's always this question: why is the universe right-handed? Why are there more? Why is there asymmetry that we see in the world? And this diagram explains it pretty much, because what happens when a right-handed photon enters an atom is it goes through a knot and gets twisted into a left-handed potential. The electron potentials have a negative charge, whereas the proton potentials have a positive charge. They add to zero. Okay, so there's no imbalance in the universe. It's, you can't, there's no way to create anything without creating the antithesis. You
Right.
can't.
By the way, you said when a proton or when a photon
A proton, or an atom.
goes in.
Basically, we started with just protons and electrons. The protons got together
Right.
in atoms, and the electrons hung around.
Yeah.
And exchanged momentum to avoid occupying the same state.
Did we get to why that produces right-handedness of our universe?
Yeah, because we don't see the inside of atoms. It's the equal left-handed matter is inside the atoms. So it's equal. Now, we don't have an equal amount of matter and antimatter. We only have matter, and I think that's what they're usually talking about with the imbalance. Why do we always have matter? And matter, and this is where the confusing technology comes in, depending on what perspective what scientific viewpoint you're taking. You can either say matter is right-handed or left-handed. What happens inside atoms is left-handed, but the electrons all around it are right-handed. And
Right.
everything can be considered every event can be considered an interaction between electron potentials. And basically, they can't occupy the same state, logical state. And they seem to exchange momentum over a distance. But because as we approach the speed of light, time and distance go to zero, electron interactions in some frame of reference is a local event where the time and space between them is zero. From the point of view of the photon itself.
I got lost in the last little mini set of concepts there.
But I mean, no, when you travel through space, you're skipping ahead in time. So if, and we can go over this in more detail later, it's only recently that people are starting to understand special relativity the way my father taught it to me, 60 years ago. He said, if you want to know what Einstein said, don't read about him, read him. And that was an important lesson because people just have crazy ideas about what he said. And, it's sort of like when you read a research paper and you read the conclusions, and then you look at the data.
Right.
So, well, they put a spin on it. That is what they want to believe, or what they think they believe, whatever.
Yeah, I think I just put something together. So all this blue, because kind of in the world of time, it's all kind of electron momentum influence. Like that's how in time everything interacts.
Right.
So then the balance on a whole to that needs to be whatever these red things are that are outside of time.
Protons, basically.
I guess.
Protons actually.
Protons.
Yeah. The delay is actually.
Oh wait.
The delay is actually caused by photons traveling between these red things. They create the time space by instantiating local delay. They only instantiate local delay. Time only is generated because they're having events. Mostly events with the vacuum energy. The energy that came from early in the universe is now hitting them.
So is that kind of sort of going back to what I was saying about the torus, where I'm kind of loosely associating the protons with the white hole of the torus. It's kind of at the center of the atom, and right at the tip of the white, where the white hole comes out. That's where actions are happening, or events are happening. And basically you're saying like put many toruses right next to each other that are all producing events, I wonder if you would put the toruses at each Planck distance.
But
And that is
nothing exists at
the,
each Planck distance, because it takes a lot of energy to approach it. I mean, to instantiate the Planck distance, requires enough energy to blow up a house. Space can't be defined that small without a tremendous amount of energy.
Mhm.
I don't know if this helps. There's a diagram of my anti-gravity machine. But and this shows actually the arrows are wrong here for what, well, depending on what you're doing. If you're talking about an anti-gravity machine, the arrows are in the right direction, but we're talking about space-time generation, and the rocket has a motor that's generating a huge number of events behind it, and all of these events manifest time space, which grows behind it, and then it's bombarded in the front with events which it absorbs. And I think of a magnet would probably be better. I didn't have one handy. I think I can delete this slide, but I'm trying to show you where the torus. I mean, I'm trying to just demonstrate. I know where the torus comes from. I don't know. I'm going to delete this image
cool.
slide. But it would be good to have a slide about that. Many people have had this vision of the
So
torus.
do you associate the electron with events and the proton with space?
No. The proton is matter. Electron potentials are space. A photon is really, they say it's a spin one particle. But if you follow the mathematics, as I did in college, what we really have is we have a photon having electron potentials going in one direction forward in time, and you have electron potentials, an electron is half spin, electron potential going the other direction. So the photon and the antiphoton together have a spin one half plus one half. But what's really being exchanged is electron potentials. And then, electron is not a physical thing. It's just a set of, it's really, you can consider it more systematic than physical. It has no properties other than 2 dimensions. It's not a physical thing in the sense of what we think of a 3D object.
Yeah, that's another question. What's this 2D? What's the nature of this 2D that you have referred to a couple times? Electron being 2D.
A Planck action is 2D. It's an orthogonal twist, lateral and transverse, say. Okay, and the creation operator creates equal and opposite twists in nothingness. Okay, and that's really what an electron potential is this twist. Two dimensions.
Mm.
I mean, technically, if you have when an
Yeah,
electron,
what's lateral and transverse?
lateral is, toward you or away from you. Transverse is side to side, up, down, any other direction besides towards you and away from you. When it twists orthogonally from the direction coming toward you or away from you, it has to be going, a orthogonal twist, it has to be going sideways some way. That's transverse.
Cool. I should just say at this point that I've kind of lost the tracking of the words with being able to visualize them. For 95% of the conversation, I was at least making an attempt, who knows if I was right or not, to be able to visualize what you were saying. And I think I was
Yeah,
getting
I
it,
think, yeah, I think trying to connect it with other ideas that you've had and things, it's probably a mistake. You got to throw everything out and start over. Okay, and then,
right.
and then when you have the whole picture, then you can relate it back to what you understood before.
Right.
Now, but
Yeah.
as you go along, you just have to build from the ground up.
Cool.
Why don't we try one more slide, see what happens?
Yeah, cool. So you want me to go up a slide, down a slide?
What do we do? We skip the slide? Slide 2, I guess.
Here's the beginning slide.
All right. And
okay. Did you want to comment on that? You commented on that while I was saying, oh, I want to go back and look at that.
That was my intention when setting this up, and initially was to describe the nature of information and the information of nature. So I don't know if I succeeded in doing that. That was, I guess, 2002. I've done some minor updates since, not much. And that diagram that I just added doesn't really belong there, but I'll leave it there anyway as a reminder to cover that area, which was not covered in this presentation previously. Okay, so we'll go to slide 2. And that's what I was just saying. It's a radically different paradigm. You got to throw out what you thought you knew. There are no fundamental fields or forces or space or time.
An information.
Okay, there's no fundamental fields or forces or space or time. There's only information about events and the logical relationship they exhibit. That's something that probably requires a tremendous amount of background, but I'm just going to leave it said for now. This is sort of what you can expect to learn eventually. Maybe wording it better would be good. Okay, let's go to slide. If you have any questions, just speak up. Go to the next slide. So
No.
did this one. Okay, the challenge, okay, what we determined is that we have, whether we consider, matrix mechanics or or whatever, it comes down, a Lie algebra, it comes down to information or logical structure rather than physical structure. We have logical relationships of things, not physical ones. Now, each quantum action, each bit, basically the amount of information is equal to the energy. Every quantum action energy answers one yes, no question. Higher, lower, left, right, up, down, faster, slower, whatever. One binary question. And to some extent, it's not determined in advance what questions we ask. Once we ask a question, it becomes manifest. The answer becomes manifest. Otherwise, it's in a superposition of states, it's not yet determined because we didn't ask yet. It's what they call the Wheeler's game of 20 questions. Strange game of 20 questions, whatever. The answer isn't determined until the end of the game. Let me get that phone. Hello. 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 I'm sorry. You can't talk now. Scam call. I'm sorry about that, but I'm expecting my wife and stuff. So, quantum doesn't directly enforce conservation of energy. That happens to be an average thing in an environment that happens, but nothing, in quantum physics, the creation operator takes no energy. You can, actually create something from nothing. But of course, it becomes a chain. In other words, if I have an electron here, one point place, and then I move the electron someplace else, I left a hole where the electron used to be. I basically created an anti-electron. I still have the original electron. Okay. Okay, nature manifests itself in discrete bits of information. And we're not discovering the information that's already there. We're instantiating information that could have possibly been there. We're creating we're selecting among the possibilities what's logically possible. And it's not surprising the universe is logical. We would expect that, I think. The idea, it's just very hard to get away from the idea of physical things.
Christopher Langan with his CTMU, that's one of his deepest concepts, is that things can't come into existence unless they come from thought or logic. And in a sense, anything stable is a yes or no, or it's a characterization. So I think that's in agreement with what you're saying.
Yeah. So let's skip ahead. Unless you have more questions.
Let me read this real quick. 'Cause
You still there?
Yeah.
I mean, it takes some time to be comfortable that the universe is logical, not physical. I mean, it's so counterintuitive to our everyday experience. Well, for most people, I would think for you it's less strange.
Right. Yeah, I'm somewhat comfortable with it. Also, I think of it as, you know, at the scales that creation happens, it's not at the scale that I live at. So it's going to be different. It's going to have a different set of rules. It's not going to be. Point being, I'm pretty comfortable with it.
There's only one set of rules. There's quantum logical systems on every scale.
All right, that's a new one to ponder.
I mean, our brain, they're discovering is a quantum logical system. You know, and I think quantum logic is the natural nature of truth. And I think I say that later on, probably in the next slide.
So can something, you know, like in my, you know, I decide something in my head, or, you know, what's a good example? I say, oh, I'm not going to sit any longer. I'm going to get up and walk outside. I guess that's because it's an emergent thing that's happening, and one could watch how that emerges in my mind. You could watch that emerge in my mind, and knowing the rules of quantum events and how they work with each other, you could model it, you could characterize it using the rules of quantum logic.
It's the same process, but you're right, it is slower. Okay, the emergence is the top-down control. Okay, if you modeled every atom in the universe and what its direction is and velocity, and use that to predict the future, you would not be able to predict whether you were going to stand up and walk outside or not. It has nothing to do with the prior state of the universe. Well, it does, because it's possible for you to get up and walk outside. Okay, that can happen, but it's not controlled by the physics of the components of your body or what anything that, you know, causing it to happen from basic forces or whatever. It's happening because existence requires an observer. If nobody observes it, it doesn't exist. If it does, it doesn't exist. And in order for the universe to be the way it is, out of all possible logical systems, there are some logical systems that include observers. And those are the ones that manifest. All the possible universes is just like Platonic imaginary things, but they're possible. You know, any logical system you can conceive of is possible. You can build it with quantum logic. You know,
And you can't restrict it to any finite number of dimensions because you can make it more complex and have more dimensions. Dimensions are created locally. You know, Einstein, the one thing that Einstein, I think, was wrong about is the idea of the block universe, that time is a dimension like others that goes both ways. Time,
Right.
as it's manifest, is only manifest by a delay, by delay elements. And if you have basic logic and delay elements, you have a general purpose system that can do anything. Without the delay elements, it doesn't do anything. And if the delay elements in the logic are sufficient to explain time being manifest, why would we invent or think of some other notion of try to impose some Platonic notion of time on the universe? Everyone's trying to say, well, you know, quantum time is a problem. You know, I mean, some people don't. They say the atoms and space and time, blah blah blah. But there's no reason to introduce any other notion of time other than times, you know, event time space.
Cool. I'm having, what do you call, just a wave of emotion, which is
You want to do another slide, or you want to call it a day? Oh no, I'm
we
late
can do
for
another
another
slide.
meeting. I'm late for another meeting. I'm
Oh,
very
shit.
sorry.
That's okay.
To be continued, maybe, if we think it's worthwhile. I think this was worthwhile.
Cool.
Maybe we'll see.
Cool.